All right, last section. I know this has been a long chapter. Arithmetic and geometric sequences. Let's go. All right, so a sequence is an ordered list of numbers. So you could tell people to, line up by your birthday from, whichever one's closest to January. You could do like line up by greatest to least or least to greatest. Those would be sequences. It's an ordered list. Doesn't matter what kind of order it is. It just needs to have an order to it, so they're not just like wacko. An arithmetic sequence, this is one of the two main things you need to know today. It's a sequence in which the difference is between any two consecutive numbers is the same. So 2, 4, 6, 8, there's a difference of 2 between here. There's a difference of 2. There's a difference of 2. And it keeps on going. That's an arithmetic difference, or arithmetic sequence. So a term is each number in that sequence. And I got a slide for that in a sec. And then the common difference is the difference between each number in that arithmetic sequence. So here's that kind of in a picture here. So each one of these is called a term. So that's a term, 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 term. So they probably will say, give us the next 3 terms in this sequence. That's where that term thing's going to come from. And the common difference is the difference between each one. So in between here, there's 10. In between here, there's 10. I did this kind of a second ago. In between this one, there's 10. So there's the term and common difference. A geometric sequence, so this is the other half of our lesson today, is a sequence in which the quotient, remember quotient implies multiplication or division, of any two consistent terms is the same. So you'd have like 2, 4, 8, 16. So I'll write those even out. 2, 4, 6, 2, 4, 8, 16. You multiply times 2. You multiply times 2. Multiply times 2. And you could keep on going. And then the common ratio is the common quotient between each number in that geometric sequence. So the common ratio would be 2 on this one, times 2. So they call it a ratio instead of a difference because it's multiply and divide, because ratio would be a fraction. So it's either 2 over 1 or 1 over 2, kind of that concept. Oh, that is a horrible picture. I am so sorry. So yeah, you'd have a common quotient, or the quotient is the common ratio. So 1, 4, 16, 64, 56, 256 would be multiplying by 4 each time of the common ratio of this geometric sequence. So your big summary is an arithmetic sequence consists are constant adding and subtract. Geometric sequence are consistent multiply or divide. Or I should say or on these. Because it could go up, it could go down. And there might be even a negative in there too. That's always interesting. All right, so state whether -5, -1, 4, 7, and 11 is arithmetic. If it is, state the common difference and write the next 3 terms. So we write those numbers out. It's going to be hard to do them where it is. Take those numbers, write them out. All right, so there's, in between these two, it adds 4. Between this one, it adds 4. I'm sensing a pattern here. Just to make sure, add 4, maybe just one more. Add 4. All right, so we notice that the differences equal 4 and so on. So the terms have a common difference of positive 4. So the sequence is arithmetics, and we continue that pattern to find the next 3 terms. So let's see if they're going to do it here. So we take 11 was the last number, and since our consistent is add 4, I'm going to add 4 to make 15, add 4 to make 19, and add 4 to make 23. So the next 3 terms of the sequence are 15, 19, and 23. All right, pause this, give it a shot. All right, so here's my numbers written out. So in between here, looks like I subtract 5. From here, subtract 5. Making sure, subtract 5. Check here, subtract 5. They might try to trick you, and on the last one they changed the number, so you do need to do all of them. Subtract 5. So it looks like it is arithmetic. And my next three terms are going to be negative 8 minus 5 would be negative 13 minus 5 for that. It's going to be, add that technically. I guess you could subtract 5 more would be 18, negative 18, and negative 23. Oh, arithmetic, state the common difference. You might even just do CD to give me that. CD would be negative 5, and then next 3 you could write below that and then underline them. That's what I would do. I think that would probably be the easiest way. All right, state whether this is arithmetic or not, and then state the common difference and state the next 3 terms if it is. So let's look at these. Looks like here there's 2 between them. Between them, this one is 4. Okay, it's probably not arithmetic. So then 6, and then plus 8. So this does not have a common difference. Therefore, I can say it is not arithmetic, would be my answer. However, we could continue the pattern and find the common differences. Continue to go up. It's too late. Wait a minute, it's morning. Moving on. All right, so if we wanted to get the next ones, we could do, if it is, state the common difference and write the next 3 terms. Apparently, they still want us to, the if it is only applies to state the common difference. So we can continue the pattern by adding 10, and then adding 12, and then adding 14. So the next 3 terms would be 10, 30, 42, and 56. And go. All right, is it arithmetic or not? 17, 11, 2, negative 10. All right, there's 3 here, subtracting, minus 6, minus 8. What's that supposed to be? And minus 12? Wait, no. 3 minus 6 minus 9 minus 12. There we go. There's the pattern. So not arithmetic is all with nuance. It doesn't want us to keep going. Thank goodness. State whether this is geometric or not. State the common ratio and write the next 3 terms if it is. So we got times 2. So like times 1. Times 2 times 1 times 2 times 1. Does it have a common ratio between each one? No, because it's not consistent. It is still a pattern, but it is not a common ratio. Therefore, it is not a geometric sequence. All right, state whether the sequence this is geometric. If it is, state the common ratio and write the next 3 terms. Oh, I like this one. All right, so between 27 and 9 is a negative 1/3, or you could say is divided by negative 3. Would be another way of writing that. I think it's easier to use multiplication on this one to say times negative 3, but your answer here is actually going to be division. So negative 9 to 3 is going to be a positive 3, because we'll have negative times a negative equals a positive, and so the next one's going to be negative, and the next one positive. A big giveaway is when you see it alternating in these. If it goes positive, negative, positive, negative, positive, your common difference is probably going to have a negative symbol in it. Okay, so the common ratio is 1/3, so the sequence is geometric, and we can continue that pattern to find the next 3 terms. So I take this 1/3 right here. We're going to keep going with that. 1/3 times negative 1/3 is going to be negative 1/9, because we just multiplied. That would be 1/3 times negative 1/3. I just multiply across, equals 1 over, and then that's a positive times a negative equals a 9 equals negative. There we go. That's how we get it with that. So we do it again, negative 27 and negative 81 to come up with the next 3 terms. So my next 3 terms are negative 9 positive 20, negative 1 over 27, and negative 1 over 18. And go. All right, so this one's, I'm going to do the top one kind of the quicker way. It's like this one's times 3 or times 4. And this one's going to be times 4. Looks like times 4, times 4. So I'm actually just going to punch them into my calculator. To show my work, I would probably go, so I need to say geometric. Oops, I wrote that in the wrong place. That's going to cover up the answer. So it's going to be geometric. Common difference is going to be, or common ratio actually in this case, common ratio is times 4. And my next 3 are going to be 512 times 4. Punch that into my calculator. So I get 2048. And we're just going to skip ahead here to get those big numbers that I would just punch into my calculator. And 32, 76, 768. All right, next one's a little more complicated. So between 100 and 20, looks like there's going to be divide by 4. 100 divided by 4 is 25. Whoops. So 100 divided by 5 is 20. Or 1 over 5 is going to be probably easier to think of. So times 1 over 5. Same thing here. 20 times here is going to be times 1 over 5. Looks like we're getting the pattern here. Wait, does it go all the way across, or is it going to change on me? 4 divided by 5 would be 4 over 5. Times 5 is going to be 1 over 5 is going to be that. Yep, so it is. So I'd say geometric. Common ratio is 1 over 5. And my next 3 are going to be, so let's do them out here, 4 over 25 times 1 over 5. 5 times 25 is 125. So we have 4 over 125 would be the first one. And then 125 times 5 is 612 or 625. So 4 over 625. And I just did this again here. And then 625 times 5 comes out to 4 over 3125. And this is probably going to be in the way. And 4 over 3. Hey, I'm right. And that's all she wrote.